Hi everyone, my project is entitled Assessing the Loss of Sandy Beach Habitat for the Hawaiian Monk Seal on Niihau Island, Hawaii. The Hawaiian monk seal is a medium-sized, earless seal that is endemic to the northwest and main Hawaiian Islands. Globally, there are actually two additional monk seal species, the extinct Caribbean monk seal and the endangered Mediterranean monk seal. The Hawaiian monk seal is also endangered and protected by the Endangered Species Act and the Marine Mammal Protection Act. Monk seals spend about 2/3 of their time out at sea, and the other third hauled out on sandy beaches, corals, and volcanic rocks. And they really rely on sandy beaches for three main reasons. First, when they're not hunting or eating, monk seals love to bask on sandy beaches. And each year, they shed their hair and outer layer of skin in an annual molt. And during this time, they usually need to spend about 10 days hauled out on beaches while this process happens. And finally, when they're pupping, their pups are born in the spring on beaches and are nursed for about 6 weeks by their mothers, who stay with them the entire time. The survival of this species is already threatened by low genetic diversity, debris entanglement, and disease, and on top of these things, the loss of sandy beaches in Hawaii due to sea level rise, erosion, and human development can reduce the critical habitat needed by these seals and make them even more vulnerable to extinction. This is a map of the Hawaiian Islands. Most people only think of the main Hawaiian Islands, located in the lower right corner of this map, but they don't often realize that there's actually a large chain of coral atolls, reefs, and islands that stretch 1,200 miles northwest from the main Hawaiian Islands. And in the northwest Hawaiian Islands, there is evidence that erosion is already causing sandy beach habitat to shrink in size. So for my research question, I wanted to know whether the same was true for main Hawaiian Islands. Are we seeing a loss of sandy beach habitat in the main Hawaiian Islands due to sea level rise and erosion? So for my study area, I chose Niihau Island, the smallest, least inhabited, and least developed island in the main Hawaiian Islands. And my logic for choosing this island is that I would be able to hone in on beach loss related to tidal erosion and sea level rise, as opposed to beachfront hotel development and other forms of human encroachment. So a few more details about my study area. Niihau is a small island located about 17.5 miles southwest of Kauai, with an area of 72 square miles and a peak elevation of just under 1,300 feet. The island is privately owned, and the human population is only about 180. The main activities on the island are the raising of sheep and cattle and commercial hunting, but there are no resorts or large-scale human residential development. Average temperature is 77 degrees Fahrenheit, and annual rainfall is 20 to 40 inches, so it's relatively arid. Geologically, the island is a basalt dome, and hydrologically, there are several lakes across the island, but there are no permanent streams present. This map shows Niihau Island with monk seal critical habitat in pink, sandy beaches in yellow, and exposed bare rock in green, which monk seals could also utilize. As you can see, critical habitat extends all the way around the island, meaning that the seals probably are utilizing the entire ocean environment around the island, but probably only haul out on the sandy beaches and maybe the exposed rock as well. The beach circled in red is the beach I chose for my analysis, and I chose it at random. For my data, I used aerial imagery obtained from Google Earth Pro. Imagery from 1984 was compared against imagery from 2013, a 29-year difference. Both images were taken at an eye altitude of just under 20,000 feet. I also used critical habitat data for the Hawaiian monk seal, obtained from U.S. Fish and Wildlife's USA Critical Habitat dataset. And I'd like to point out that Landsat imagery was not used in this study because of its low resolution. at a resolution of 98 feet or 30 meters, it really didn't allow me to visualize sandy beaches clearly on such a small island. And as a result, I was unable to do several of the analyses that I would normally be able to do, like land cover, NDVI, things like that. So that was one drawback to this. For my methods, as I mentioned before, one of the two main sandy beaches on the island was chosen for the analysis. At random, two images, one from December 30th, 1984, and one from December 16th, 2013, were exported and georeferenced in ArcGIS Pro onto the World Imagery Base Map. Polygons were drawn around the sandy beach area on both images, and finally the area for each polygon was calculated. My results: the beach in 1984 was found to be just over 400 acres, while the beach in 2013 was found to be just over 336 acres. As you just saw, the results of this analysis indicate that the representative sandy beach on Niihau used in this study is experiencing change over time. Between 1984 and 2013, the total beach area decreased by 16%. Possible causes of this beach loss are erosion, sea level rise, or a combination of both. Other factors we can consider: definitely habitat degradation and erosion caused by domestic and feral ungulates. Remember, we talked about cattle and sheep ranching that was happening on the island, and also hunting of game animals. Both of those activities could definitely play a role in trampling of vegetation, which could lead to erosion. A few considerations: had I chosen the other beach on the southeast side of the island, I might have gotten different results. On the island of Oahu, my home beach on the northeast side of the island, Kailua, is experiencing accretion, experiencing a lot of sand deposition, while other beaches elsewhere on the island are experiencing a lot of erosion. So choice of beach and side of the island both matter due to tides, currents, wind, and wave action. Also, pulling imagery from different years could have yielded different results for this study. Large storms or drought conditions can definitely affect vegetation and sand erosion on beaches. And finally, the 1984 image that I pulled from Google Earth Pro had a much lower resolution than my 2013 image, which made drawing the polygons slightly more difficult. So some error could have been introduced during that process, although the contrast between the white sand and the darker ocean and vegetation around it made it relatively easy to create the feature, but I did just want to point that out as well. That is all. Here are my sources, my literature, and my data and imagery. I hope you enjoyed my presentation, and I look forward to hearing your comments. Thanks so much.